Okay, Jonathan here at Colfax Math. I'm going to go over functions. This is for either an integrated 3 class, algebra 2 class, or pre-calculus class, kind of all preparation for calculus. There's really, everything's kind of split into 5 different functions. The first one is linear. The second is exponential. Third is some form of nth power. Fourth type of function would be quadratic. And the fifth would be periodic. So periodic's really the whole term in trigonometry, and I'm not really going to look at that in this section right here. Linear, you've been studying for years. It's y equals mx plus b. It's a straight line. It could either be direct or inverse. As x goes up, y goes up. It's direct linear. Or you could have a negative slope, and inverse linear would be as x goes up, y goes down. An exponential function is y equals a times b to the x. And giveaway on this is that when x is 0, anything to the 0 power is equal to 1. So it has a y-intercept, something above the origin. So that's direct exponential. X is going up. As x goes up, y goes up at an increasing rate. So an increase in x leads to an ever-increasing rate in y. So that's exponential. You could also have inverse exponential. Inverse exponential would be, as x gets larger, y gets smaller. Nth power, y equals k x to the n. And n could be any number from 1, which would be really the same as a linear function, to 7.3. It doesn't have to be an integer, or it could be in the denominator, and it could be inverse nth power as well. So nth power starts at the origin, 0, 0, direct inverse, or, I'm sorry, that would be direct nth power, or inverse nth power, going down. And then quadratic, also a big part of algebra 2, would be y equals ax squared plus bx plus c. And then, a lot of these are parabolas. These could be direct or inverse as well, probably with a given domain. So all of this is based on the idea that x is your independent variable on your horizontal axis. Y is your dependent variable on the vertical axis, and a function, sometimes denoted with f of x, that just means it is a function. A function is defined as only one corresponding value for only one corresponding y value for any given x value. So you could check that with the vertical line test. So if I have a function like that, if x is equal to 5, I could see there's only one corresponding y value, and whatever that is. So the vertical line test is if it crosses a graph in only one place, yes, it is a function. Or if the vertical line crosses a graph in more than one place, no, it is not a function. So not a function if a vertical line crosses it in more than one place. Okay, so that's kind of the overview of functions. Then just look at composite functions first, and then inverse functions, or finding the inverse, different than direct and inverse up here. So composite, sometimes written f of g of x, or it can be written f of g of x. And let's say I have a function f of x equals 3x plus 2. That would be a linear function, and g of x equals 5x squared. That would be nth power. And then if I want to find f of g of x, I would say take g of x and plug it in here, right? So f of g of x would be equal to 3 times x, and x is equal to 5x squared. and then, so it's 3x plus 2. Then I simplify that is 15x squared plus 2. So f of g of x is equal to 15x squared plus 2. If I wanted f of g of 2, I would say take 2, plug it in a f of g of x. So I would take that 2, plug it right in there, and f of g of 2 would be equal 15. We're saying x is equal to 2. I'm plugging it in there. Squared plus 2. Rules of exponent, order of operations is exponents first. So I'd have 4 times 15, 60, plus 2, or 62. Okay, so that's a composite function. And then from composite functions, I'm going to just look at an inverse. So if f of x, again, is still equal to, say, 3x plus 2, and I want to find the inverse function of that, f of x and y are the same, so I have y equals 3x plus 2. And then to find the inverse, the rule is switch your x's and y's and solve for y. So I would have x equals 3y plus 2. Swap my x's and y's, solve for y. Subtract 2 from both sides. Divide both sides by 3. And now y, after I switch x and y is equal to x minus 2 over 3. So if my function is f of x equals 3x plus 2, the inverse function of x would be x minus 2 over 3. If I find the inverse function and plug 3 in for it, then that would be equal to the inverse function with 3 plugged in for x. So that 3 would go in here. 3 minus 2 over 3, 1/3. So the inverse function is x minus 2 over 3. The inverse function with 3 plugged in is 1/3. Okay, so that's functions. The next thing to kind of know are logarithms. And the reason why we're learning logarithms right now, or reviewing logarithms, not learning logs, is that if you're working with an exponential function and you have to solve for x, you have to use logs to do that. Okay, so the next thing is really looking at logs. I won't do a whole thing on logs, just a quick review of the definition of logarithms. The important thing about log base b of x equals n, is a definition. This is my base. To the power of that is equal to x. Okay, and then the first property of log is log base b of x to the m. The first property of logs says you could bring that m down in front to get m log base b of x. Okay, so that's kind of the first overview of functions. I know there's a lot right there. And now we're going to start looking at, given a set of data, how to identify what kind of function it is. This is kind of the set of notes you're going to need right here, the 4 different kinds of function and their general equations. Okay, so let's say I have different sets of data and I'm trying to figure out the relationship. I have 4 things to choose from, really. Linear, exponential, nth power, and quadratic. And I go through a process of elimination. So the relationship in linear, right, is plus a constant, so plus 2, plus the same constant, plus the same constant. So plus 2, so this is increasing by adding 2 each time. Then on the right side, it's adding 4, adding 4, adding 4. So you're adding a constant, one constant on the left, and adding a different constant on the right. And if that works, then it's a linear function. Okay, so if the problem was given a linear function, find f of 9, well, that would be easy because this is plus 2, plus 2, plus 2, plus 2, plus 4, plus 4, plus 4, plus 4. It would just be 26. Okay, and then the next set of data I have here is I'll check to see if it's linear. So I'll check to see if it's linear. So is this linear? It would have to be plus 2, plus 2, plus 2, which it is. But then it would have to be plus 36, plus 36, plus 36. It's not. So it's not linear. So after I try linear, I'll try exponential. For it to be exponential, it would be plus a constant on the x side. So plus 2, that works all the way down. And then this would have to be times a constant. So how do I get from 12 to 48? I multiply by 4. 48 times the same constant is 192. 192 times 4 is 768. So yes, it is exponential. Okay? So again, a linear set of data has a constant increase in x, constant increase in y. Exponential set of data has a constant increase in x with a multiplied by a constant in y. And then here's my third set of data. I'm going to try this. Again, I'm going to go through this process of elimination. Is it linear? Plus 2, plus 2, plus 2, that works. Plus 36, plus 36, that does not work. So it's not linear. Is it exponential? Plus 2, plus 2, plus 2, that works. Times 4, that does not work. So it's not exponential. So now I'm going to go to nth power. For it to be nth power, I'm not going from 1 to 2 and then 2 to 3. I'm always going back to my first. For it to be nth power, this would have to be times 2, and then this would also have to be times some form of 2. So how do I get from 12 to 48? I multiply by 4. So I turn that 4 into a factor of 2, so 2 squared. So then how do I get from 2 to 6? I would have to multiply by 3. And here I would also have to multiply by 3 to the same power of n. So 12 times 9 is 108. 2 times 4 is 8. And then this would have to be 12 times 4 squared. 12 times 16 is 192. So yes, it is nth power. Okay, so this process of elimination, let me go to my last set of data here, see if it's linear. Plus 2, that works. Plus -8, plus -8 doesn't work. Is it exponential? Plus 2 times 5/13 times 5/13, that does not work. I'll try nth power. Times 2 to the n. Times 3 to the n. That's obviously not going to work, so it's not nth power. So then I finally check my fourth possibility, quadratic. If it's a quadratic, the difference of the differences is a constant. So let me look at the difference in the y values. How do I get from 13 to 8? I'm sorry. How do I get from 13 to 5? I subtract 8. How do I get from 5 to 5? I add 0. 5 to 13, I add 8. 13 to 29, I add 16. That's the difference of my y values. I then look at the difference of those. -8 to 0, I add 8. 0 to 8, I add 8. 8 to 16, I add 8. The difference of the differences is a constant. Yes, it is a quadratic. So it's a process of elimination. If I have a set of data like this, then I could identify it as linear. And if I have a set of data like this, I check to see if it's linear. If it's not, then I go to exponential. So if it said, yes, you have an exponential function, this is a data set, find f of 10. Well, f of 10 would just be 768 times the same constant 4. So 768 times 4 would be 3072. And then if it's not exponential, then I check nth power. And then finally, if it's not nth power, I check to see if it's quadratic through the difference of the differences. So that's kind of the most important part, is really identifying the function. Okay, once I identify the function, then I know its general equation. So step 2 is know the general equation. And you just need to know these. So general equation for linear is y equals mx plus b. For exponential, y equals a times b to the x. Nth power, y equals k x to the n. And quadratic, y equals ax squared plus bx plus c. Here I have two unknowns. I need two, in the linear function I have two unknowns. To solve for m, I could do rise over run. Pick two values, a rise over run, and solve for this specific equation. Here I have two unknowns, a and b. I pick 2 points. I divide through and solve for a and b. Nth power, k and n need to be solved for, so I pick 2 points. With a quadratic, I actually have 3 unknowns, a, b, and c, so I have to create 3 equations. Okay, I know I'm doing a lot here. I'm going to keep going though. So if your data is not this clean, there's another way to figure out its relationship. Okay, so here's my set of data. If it's a nice clean set of data, all integers, I can know those relationships. And if it's not, then I'm going to go to what's called semi-log and log-log paper. I'm still doing the exact same thing as I was doing before. I'm really trying to identify, is it linear, exponential, nth power, or quadratic? And I'm going to do that through a process of elimination still. This is semi-log paper because it's arithmetic in x, logarithmic in y. When I label this is like regular graph paper, 0, 1, 2, 3, just like you would regular graph paper. However, in the logarithmic scale, it's factors of 10, so they're logs. So I start at 10 to the 0, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now I'm going by factors of 10. So now I go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Now that I'm at 100, I go by hundreds. 200, 300, 400, 500, and so on. Okay, so this semi-log graph paper. Okay, turn this over on the back of this. This is actually logarithmic graph paper. So it's logarithmic in both directions. 1, 2, 3, 4, 5, 10. And for this logarithmic here, I'm going by tens now to 100. And this cycle to 1, 2, 3 to 10, 20, 30, 100, 200, 300. So I have 3 types of graph paper. I have regular graph paper, which is called arithmetic. I don't have any in front of me, but it's just a regular graph paper you're used to. Semi-log graph paper and log-log graph paper. So now let's go back to those same set of data points I had here, like this. And I'm going to go through the same process of elimination. So if I had a set of data like this and I want to know what it is, I could graph it on regular graph paper, right? Over 2, up 12, over 4, up 48, over 6, up 108, and I could see it's not straight on regular graph paper. So if I have a set of data like this, it is going to not be linear. For it to be linear, it would have to be straight on regular graph paper. Then I'm going to check exponential. For it to be exponential, it would have to be straight on semi-log graph paper. So I'll graph these points, over 2, up 12. I don't know if you can see that. Over 2, up 12. Over 4, up 48. Over 6, up 108. And over 8, up 192. Then if I put a ruler on that, It is not straight. There's no way I'm going to get a straight line out of that. So it's not straight on exponential. It is not exponential because it's not straight on semi-log. Okay, so this is my set of data here. I graphed it on regular graph paper. It was not straight, so I know it is not linear. I graphed it on semi-log paper. It was not straight. I know it's not exponential. Now I'm going to graph it on log-log paper. If it's straight, then yes, it is nth power. So here's my log-log graph paper. My set of data, I'm over 2 up 12. I'm over 4 up 48, over 4 up 48. Over 6 up 108, 6, 108. Over 8 up 192, 192. So those are my 4 data points on log-log paper. I can see when I put a ruler on them, I'm pretty close. It's straight, so yes, it is nth power. So if you have a clean set of data, through a process of elimination and looking at the relationship, you can figure out if it's linear, exponential, nth power, or quadratic. If it's not a clean set of data like 1, 5, 6, 20, and it's jumping all over in the x direction, then you want to graph it. If it's straight on regular arithmetic paper, then it's linear. If not, go to semi-log paper. If it's straight, it's exponential. If not, go to log-log paper. If it's straight, then it's nth power. If not, check the difference of the differences. If that's a constant, then it is quadratic. A lot of information. That's how you identify the function. And I'll just go over my last little part of this is once you've identified it, my 5-step process with all of these problems. So let's look at this exponential data here. So it's a 5-step process. Step 1 is to identify. Step 2, know the general equation. Step 3 is find the specific equation. Step 4 is check it and make sure when you check that equation that you're not using one of the points that you use to solve for the equation. And step 5 is use it as a model. Okay, so use it as a model. So let's say this set of data here, I've identified it as exponential. So step 1, this is exponential data. Step 2, I know the general equation for exponential is y equals ab to the x. Step 3 is find the specific equation. I pick one point, y, 48, equals ab to the x. A second point, 12, equals ab to the x. Divide one equation by the other. 48 divided by 12 is 4. a to the first divided by a to the first. I subtract exponents to get 0. So a to 0 is 1. Subtracting exponents here, I get b squared. Square root of both sides, b is equal to 2. Take that value of b, plug it back in to solve for a. All right, so that's 2 squared, 4. 4 times 3 is 12, so a is equal to 3. I have value for a and b both. From my general equation, I go to my specific y equals a times b to the x. Step 4, check it with a different data point. So I'll pick that 6. Is 192 equal to 3 times 2 to the 6? 2 to the 6, 2, 4, 8, 16, 32, 64. 64 times 3 is 192. Yes, it is. It does work. In step 5, use it as a model. Say find f of 10. So I have y is equal to a times b to the 10th. And 2 to the 10th, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. 1024 times 3 is 3072. So that's kind of really the whole point of this whole function thing, is to given a set of data, identify it, know the general equation for it, be able to find the specific equation, double check that you did it correctly, and then be able to use that as a model. So again, the top 5 functions you need to look at are linear, exponential, nth power, quadratic, and the 5th is periodic. And periodic is really the first half of the course, and you can study my trig videos on that. All right, and go through that process of elimination. I sure hope that helps. Epically long video, but that sums up chapter 6. Thank you for watching. Good luck.